transform pair. If you look at the formula sheet, in the fourth page of that sheet, there are some standard results are given. Okay, standard Fourier representation of typical signals. So we'll be using some of those Fourier representations. Mainly, okay. First, let me explain you. Mostly we'll be using these two results. We already discussed this. If we consider a rectangular pulse minus t1, its Fourier transform is 2t1 sinc omega t1 by pi 2 sine omega t1 by omega. I think this form is given in the formula sheet. Okay, 2 sine omega t1 by omega. And if you look at the formula sheet, it is this is represented by, okay, rect function is this one. This is called rect t. It is a rectangular pulse of width 1. Okay, minus 1 by 2. This is rect t. And you can see that this is a scaled version of this a standard rectangular pulse. And its form is is it t by 2 t1, right? It is t by 2 t1. Okay, because this point is 1 by 2, and if you want to make it t1, you have to scale it by a factor of how much? How to get this from this? This is the standard rect function width 1. If you want to make it a rectangular pulse of width 2 t1, what is the operation? Is it t by 2 t1?
Yes, sir.
Yes, sir.
So this is this one. And another, if you look at the formula sheet, another result is given. That is, if you consider a rectangular pulse in the frequency domain, if the Fourier transform of a signal is a rectangular pulse, and if it is w and minus w, this is a function of omega, and its Fourier transform is sine wt by pi t. So if it is a rectangular pulse in the time domain, it is a sinc function in the frequency domain. And if it is a rectangular pulse in the frequency domain or Fourier domain, then it is this is a sinc function. Okay. Now using this result, we can start the first problem. 1a. Xt is equal to e to the power. So tell me, what is the Fourier transform? So it is this is non-zero when mod t is less than pi, and 0 for mod t greater than pi. And non-zero means e to the power j10t. So can we write this as xt as a rectangular pulse multiplied with e to the power j10t? Is it xt?
Yes, sir.
It is a rectangular pulse. What is the width of this pulse? This is pi and minus pi, isn't it? It's a rectangular pulse.
Yes, sir.
Multiplied with a complex exponential. Now which property can we use?
Time multiplication.
Sorry, there is a property, frequency shifting property. If xt Fourier transform is x of j omega, then xt e to the power j omega naught t, it is x of j omega minus omega naught, isn't it? That is a frequency shifting property. So now tell me, what is the Fourier transform of this? If you compare with the standard result, you can see if it is tell me, what is the value of t1 here? What is the Fourier transform of this rectangular pulse? Look here, this one is t1, here t1 is pi. So it is 2 sine omega pi divided by omega. That is Fourier transform of this rectangular pulse. Now, if you are multiplying with a complex exponential, then what is the Fourier transform? What is the operation? You have to replace omega with omega minus omega naught. And here omega naught is how much? Is it 10?
Yes.
Yes, sir.
So what is the answer? 2 sine omega minus 10 divided by omega minus 10. Okay,
Student sinc function.
Sorry, this is a sinc function only. If you write it in the sinc form, if you are using the sinc form, this is 2t1 sinc omega t1 by pi. That is the Fourier transform of this rectangular pulse. Now, if you apply the frequency shifting property, multiply this with e to the power j 10t, you have to replace omega with omega minus 10. So the answer is 2t1 sinc omega minus 10 into t. Sorry, it is not t1 is pi divided by pi. Okay, you'll get the same answer. These are same. Okay, so 1b, using the property, we have to find the Fourier transform. I think there is one property, differentiation property. I am not sure whether I discussed it in the class or not. The differentiation property is that if xt, Fourier transform of xt is x of j omega, then the derivative of xt, its Fourier transform is j omega into x of j omega. That is the differentiation property. And it is straightforward to derive this. This one, it is given in the formula sheet also. Now, using the properties, which standard result we have to use? If you look at the formula sheet, there is a standard result given, e to the power minus, e to the power minus at ut. It is 1 upon a plus j omega. And this is for, okay, it is not mentioned there. This is valid only if a is greater than or equal to 1. Okay. Now, can you tell me which properties, how many different properties we have to use here? There is a convolution and differentiation. So both convolution and differentiation properties of this Fourier transform we have to use here. E to the power minus 3t ut. The Fourier transform is 1 upon 3 plus j omega. And e to the power minus t. Can you tell me what is the Fourier transform of e to the power minus t ut minus 2? What is the Fourier transform of this?
One upon 1 plus j omega into e to the minus 2 omega.
1 plus j omega into e to the power
Minus 2 omega.
minus j2 omega, isn't it? Is it?
Yes, it is.
This is the time shifting property. Now, what is the Fourier transform of this? E to the power minus t ut minus 2?
Multiply by e to the power minus 2.
So e to the power minus t minus j2 omega into e to the power minus 2, because you have to take this here using the linearity property, 1 plus j omega, isn't it? Okay. Now, what is the convolution property? Convolution of two signals in the time domain, then it is multiplication in the Fourier domain, isn't it? So what is the final answer? There is a differentiation, convolution of these two signals and differentiation. Differentiation property is that it is a Fourier transform of this signal multiplied with j omega. So is this the final answer? J omega into what? 1 plus 3 plus j omega into e to the power minus j2 omega into e to the power minus 2 divided by 1 plus j omega.
Yes, sir.
Okay. This is the signal, time domain signal xt given. And first part of that question is you have to determine gt such that xt is equal to sine pi t by pi t into gt. Okay. You have to determine the signal gt such that xt is equal to sine pi t by pi t into gt. What is gt? Which property we have to use here? Which property? It is the property of delta function, isn't it? What is the shifting property? If you remember, there is a property called shifting property. The property is that if you multiply any signal with a shifted delta function, what is that? If you multiply any signal with a shifted delta function, what is the resulting signal?
X of t naught into delta t minus t.
It is x t naught into delta t minus t naught. It is not x t naught. It is x t naught into delta t minus t naught. That is called the shifting property. It is straightforward because this delta function is non-zero only when t is equal to t naught. So we can write like this. Okay. Now tell me what is gt here? Can we write this xt as, look here, it is delta t minus k pi by 4. And here also it is k pi by 4, k pi by 4. So can we write this as sine t by t is it?
Yes, sir.
Because if you take this inside the summation, this is non-zero only when t is equal to k pi by 4, so you'll get this. Now what is gt here? You have to convert it into this form, sine pi t by pi t. Sorry, it is sine t by pi t. In the question, it is given as sine t by pi t. So what is gt here? Is it this?
Yes, sir.
Yes. Okay, now the second part of that question is to use the multiplication property of the Fourier transform to argue that xj omega is periodic. So we have to find xj omega and then we have to show that it is periodic. Okay, periodic in omega. So which property we can use? Can we use the multiplication property of Fourier transform? Consider this as one signal and this as the second signal gt. Find the Fourier transform of these two. Find the convolution. Because multiplication in the time domain, it is the convolution in the Fourier domain. So the Fourier transform of x of t is Fourier transform of this, convolution, Fourier transform of this. And there is a scaling factor 1 upon 2 pi. Okay. Convolution property is that x1t, if its Fourier transform is x1 j omega, x2t, then x1t convolution x2t, its Fourier transform is 1 upon 2 pi. It is minus infinity to infinity x1 j u x2 j omega minus u du. That is a convolution of x1 j omega and x2 j omega. Okay. So tell me what is the Fourier transform of this? Let me write it as x1t. x1t is sine t by, okay, this one is, okay. So we have to find it in this form. So this is pi t into pi t. So this is sine t by pi t. What is the Fourier transform? This is the standard result given in the formula sheet. Sine wt by pi t, it is rect omega by 2w. Okay, so this is a rectangular pulse in the frequency domain. And what is the width of that? What is the value of w here?
1.
Is it this? 1 minus 1. Because the value of w is 1 if you compare these two. Is it?
Yes, sir.
So this is x1 j omega. Fourier transform of the signal sin t by pi t. Now what is the Fourier transform? This is gt. What is the Fourier transform of gt? Its Fourier transform, let us denote it by g j omega. What type of signal is that? Is it a periodic signal? What signal is this? This is a periodic signal. And what are the Fourier series coefficients? Remember the standard result. If you have an impulse train, let's say 0 t naught like this, its Fourier series coefficients are what?
1 upon
1 upon t naught for all the value ak, or 1 upon t naught for all the values of k, isn't it? This is ak is equal to 1 upon t naught for all the values of k. Now, what is the Fourier transform of a periodic signal? What is the expression? If ak are the Fourier series coefficients and omega naught is, if ak are the Fourier series coefficients and omega naught or t naught is the fundamental period of that signal, then what is its Fourier transform?
2 pi by t naught delta of omega minus k
It
omega.
is, the standard form is summation k minus infinity to infinity 2 pi ak into delta omega minus 2 pi by t naught, isn't it? Sorry, there is something missing here. K. 2 pi k by t naught. This is the Fourier transform. If we know the Fourier series coefficients of a periodic signal, this is how we compute its Fourier transform. Now, what is the value of t naught here? T naught is what? This is the signal gt. What is the fundamental period of that signal?
Pi by
T naught is pi by 4. Is it? And ak, what is ak? AK is what?
4 by
4 by 5.
4.
AK is power, that is 1 upon T naught, that is 4 by pi. Okay. Now if you put this value here, what is G of j omega? There is a pi here. So summation k minus infinity to infinity. Okay, so there is a pi here. And AK is, so 2 pi into AK is 4 by pi into what? Delta omega minus 2 pi k divided by T naught is pi by 4, isn't it? Is it the Fourier transform of GT?
Yes, sir.
Okay. Now, if we simplify this, can you tell me, is this an impulse train? I'm just sketching that. Is it an impulse train?
Yes, sir.
It is an impulse train. And tell me what is this this value? This is a function of omega because g of j omega. This is function of omega. What is this?
8.
It is 8, 16 like that, minus 8. And what is the strength of that impulse?
8 pi.
8 pi.
Strength is this one. Is it 8 pi? Yeah, it is 8 pi. Strength is 8 pi. Okay. So the given signal xt is, this is x1t into gt. So we found the Fourier transform of x1t and gt. Now we can use the multiplication property. What is multiplication property? Multiplication in the time domain is convolution in the frequency domain. And there is a scaling factor of 1 upon 2 pi. Now, can you tell me what is the convolution of these two? What is the property of convolution, delta function? Convolving with delta function. If you convolve any signal with a delta function, what is the result?
Function itself.
And if you shift it, if it is a shifted delta function,
Function gets shifted by the same.
by the same. So tell me the answer. You can directly sketch that. What is the convolution of this with this impulse? Is it this itself?
Yes, sir.
So this one, this is 0, 1, minus 1. Now what is the convolution with this shifted impulse? This one shifted right.
To the right by
So this is 8, 9, and 7. So similarly, you'll get a, if you shifting with the convolving with this one, you'll get one in the negative side. So it is 0. Sorry, it is minus 8, minus 7, minus 9, like that. Okay. Is it a periodic function of omega? Is it periodic?
Yes, sir.
It is periodic. It is a periodic function of omega. And what is the amplitude?
4.
Amplitude is 4 because this one is 8 pi and there is a 1 by 2 pi here. If you multiply these two, it is 4. Okay. So this is the answer. It is a, you have to, we have proved that it is a periodic function of omega and we have determined the expression for that Fourier transform also. Okay.